Good morning. I'm Dr. Vishwakumar M., Professor in the Department of Mathematics, Reva University. Today we are going to discuss about successive differentiation in differential calculus, which comes under Module 1. So I'm going to take Module 1 and we are going to study successive differentiation. What is the successive differentiation? If you differentiate any function successively, the process which we are going to adopt there is called as successive differentiation. For example, if you take y as a function, if you differentiate this first time, you are going to get y1, the first derivative. If you differentiate this y1 again with respect to x, you are going to get y2. If you differentiate the second derivative y2 again with respect to x, you are going to get y3. Keep on doing the same, you are going to get yn. Now this represents nth differentiation of the given function. This process of differentiation is called as successive differentiation. Right? These are all the derivatives in the process. First derivative, second derivative, third derivative, nth derivative. Now we can represent this derivative notation in other format also. So first derivative y1 can be represented as dy by dx. We can also write y1 as dy by dx. This can also represent d, capital dy, can also represent y dash. Right? Now second derivative can be represented as d square y by dx square. And here we can write this as d square y, and here it becomes y double dash. Right. So keep on doing this. Nth differentiation can be represented as dn y by dxn. Correct? And this is dn small y, and here y power n. These are the different possible ways of representing our derivatives in successive differentiation. Correct? Now we are going to study the nth differentiation of some standard functions in maths. What are those standard functions? Standard function means it may be exponential function, it may be logarithmic function, it may be algebraic function, it may be trigonometric function, or product of these. Now first we are going to consider the exponential function y is equal to e power ax. Correct? Now what is the first differentiation of this y1? Now what is the differentiation of e power ax? It is a e power ax. A e power ax. Now I want to differentiate this one more time. This a acts as constant. I'm going to keep as it is. What is the differentiation of e power ax? This is again a e power ax. So I'll write e power ax. A into a becomes a square. Now I'll differentiate one more time. A square I'm going to keep as it is. What is the differentiation of e power ax? It is a e power ax. So this becomes a cube. A square was there already. One more a will come. It becomes a cube e power ax. So one can easily judge what we are going to get in the next term. So y4 will be a power 4 e power ax. Correct? Now it is in a proper order. From this order we are in position to judge what we are going to get in nth term. Correct? See, for y1 it is a power 1, for y2 a power 2, for y3 a power 3, y4 a power 4. In yn what it should be? It should be a power n. Correct? And e power ax is there in all the terms. Now here also we are going to take the same. We are going to get e power ax. So nth differentiation of e power ax is equal to a power n e power ax. Correct? This is the nth differentiation of e power ax. Now we are going to take the nth differentiation of constant to the power x. So I'm going to take second one. Y is equal to constant to the power x. What is the differentiation of this? It is a power x log a. A power x log a. How are you going to get this one? Maybe a bit confused one. So simple. I can take y is equal to a power x. We can take log on both sides. We're going to get log y is equal to log a power x. Concentrate this one. This looks like log m power n. Correct or not? Can be written as n log m. So I can write x log a. Now differentiating this, I'm going to get 1 by y, because log y differentiation is 1 by y into dy by dx. I can represent that as y1. Log a is constant. I'm going to keep that as it is. Differentiation of x is 1. But I need only y1. Cross multiply y that side. I'm going to get y log a. But what is my y? A power x. So y1 is a power x log a. So the nth differentiation of a power x is, differentiation of a power x is a power x log a. So I'm going to get now second differentiation. So log a is constant. Differentiation of a power x is a power x into log a. So log a into log a becomes log a whole square. Now if you differentiate one more time, so log a whole square will be same as it is, but a power x differentiation is a power x into log a. Now this power 2 becomes 3 now. So one can easily get what we're going to get in the next term. So y4 is a power x log a whole power 4. Since because of the proper order, one can easily judge what we're going to get in nth term. See, a power x is there in all the terms. Now here also it will be. And here log a. See, for y1 log a power 1, y2 log a whole square, y3 log a power 3, y4 log a power 4. For yn it should be log a power n. So therefore nth differentiation of a power x is a power x log a whole power n. Now this is the nth differentiation of a power x. Now we'll take the nth differentiation of algebraic function. Okay. Now I'm going to take y is equal to ax plus b whole power m. This is an algebraic function and which is of the form x power n format, and we know the differentiation of x power n is m x power n minus 1. So what is y1 then? It is m ax plus b whole power m minus 1 into inner differentiation of this is a. Correct? Or which we can also call it as chain rule. Now for the next differentiation, this m and a acts as constant. What is the differentiation of ax plus b power m minus 1? It is m minus 1 ax plus b power m minus 2. Correct? Into inner differentiation of this is one more a, it becomes a square. Now y3 m minus 1 we are going to keep as it is. Now the differentiation of ax plus b power m minus 2 is m minus 2 ax plus b power m minus 2 minus 1 becomes minus 3. Ax plus b inner differentiation is a. Already a square is there. Can I write that as a cube? Yes. So one can easily write the next term. Similarly, we can easily write down y4 is m minus 1, okay, m minus 2, m minus 3, ax plus b power m minus 4, a power 4. Correct. Now carefully observe this. We have got a proper order. So from this we are in position to judge what we are going to get in the nth term. See, for y1 a power 1, y2 a power 2, y3 a power 3, y4 a power 4. In yn it should be a power n. Correct? Now power if you go with ax plus b whole power. See, for y1 it is m minus 1. For y2 m minus 2. For y3 m minus 3. y4 m minus 4, and here it should be m minus n for nth term. Correct? Now for y1 it is only m. y2 it ends with m minus 1. This 1 is 1 less than this. For y3 it ends with m minus 2. This 2 is 1 less than 3. For y4 it ends with m minus 3. This 3 is 1 less than this 4. So I can write this as m minus 1, etc. m minus n minus 1. Correct? So this is the nth differentiation of ax plus b whole power m. That is m, m minus 1, etc. M minus n minus 1 ax plus b power m minus n into a power n. This is the nth differentiation of algebraic function. Correct? Now we are going to take a properties based on this algebraic function. Now the simple question is, what is nth differentiation of x power m? Now one can ask me, sir, if I want to give the answer for this one, so we should know the relation between m and n. Correct? Without knowing the relation between this and this, it's not possible for us to give the exact answer. Now first case, if I take when n is equal to m, when n is equal to m, so nth differentiation of x power m is n factorial. How? Simple example I'm going to take it. So I'm going to take d cube of x cube. I'm going to take d cube of x cube. What is the first differentiation of x cube? 3x squared. Correct? What is the second differentiation of this? 6x. What's the differentiation of 6x? 6. Can I write that as 3 factorial? Yes. So d cube of x cube is 3 factorial. See here, m and n are same. So therefore it is n factorial. Correct? So d power 4 of x power 4 is 4 factorial. D power 5 of x power 5 is 5 factorial. So like that, d power n of x power n or x power m, when n is same as m, we can write that as n factorial or m factorial. Now what it will happen when n is greater than m? What it will happen when n is greater than m? This n is greater than this. So we'll take one example there to get to know what has happened. So d cube of x squared. This time I've taken x squared, not x cube. See, this n is greater than this m. Correct? So what will be the first differentiation? It becomes 2x. What will be the next differentiation? It becomes 2. What will be the differentiation of 2? 0. Because 2 is a constant term and the differentiation of that will be 0. So d cube of x squared is 0. Why? Because this n is greater than this m. So when this is greater than this, it will be obviously 0. Now we'll take the nth differentiation of logarithmic function. So y is equal to log of ax plus b. Correct? Now what is the first differentiation? y1. What is the differentiation of log x? It's 1 by x. Correct? In the same way here, I'm going to get 1 divided by ax plus b into differentiation of this will be a. Now we can rewrite this as ax plus b whole power minus 1 into a. Correct? So now I'm going to differentiate this. This looks like x power n format and the differentiation of that is minus 1 ax plus b power minus 1 it will be minus 2 into a squared. Because already one a is there. If you differentiate this ax plus b internally, you're going to get one more a and we're going to get a square. So what is y3? Means the third differentiation, minus 1 a square will remain same. So this is x power n format. Differentiation of that is minus 2 ax plus b whole power minus 3. Correct? Into one more a will come. So this becomes a cube. Similarly, one can easily check what we are going to get in the next term. y4 is minus 1, minus 2, minus 3, ax plus b whole power minus 4 into a power 4. Correct? So one can easily observe we have with us a proper order. From this proper order, we are in position to judge what we are going to get in nth term. See what we are going to get in yn. See, for y1 a power 1, y2 a power 2, y3 a power 3, y4 a power 4, y5 a power 5, yn, it should be a power n. Correct? Now, if you go with the power of ax plus b, see, for y1 it is minus 1. y2 minus 2, y3 minus 3, y4 minus 4, y5 minus 5. For yn, it should be minus n. Correct? Now for y2, it will be 1 with negative sign. So 1 is 1 less than this. So y3 ends with 2, 2 is 1 less than 3. y4 ends with 3, 3 is 1 less than this. So for yn, it should be, starts with 1, 2, etc. It should be 1 less than n, that is n minus 1. Correct? Now carefully observe these terms. How many terms are there here? N minus 1 terms. So all the terms are having negative sign. If I take that n minus 1 negative sign outside, I can write that as minus 1 power n minus 1. Remaining terms 1 into 2 into 3 etc. into n minus 1. Because of this minus sign in the power, I can write that term in the denominator ax plus b whole power n. This a power n, I am going to keep it as it is. Now I can write down this as minus 1 power n. Correct? And what is this 1 into 2 into 3 into etc. n minus 1? It can be written as n factorial. Correct? A power n whole divided by, I can write down this as ax plus b whole power n. This is my yn. Means what? Nth differentiation of log of ax plus b is minus 1 power n, n factorial, sorry, n minus 1, no, this is n minus 1 factorial, this is n minus 1, this is n minus 1 factorial, and a power n and ax plus b power n. Correct? So this is the nth differentiation of logarithmic function. Today's session we can end up here. In the next session we are going to study the nth differentiation of trigonometric function and inverse trigonometric, etc. And thereafter we are going to take the examples on the same. Thank you.